Hello everyone, my name is AB, and once again I'm coming your way with another math topic. And today we are going to discuss a topic called modular arithmetic. Modular arithmetic. When we talk about modular arithmetic, we are entering into a different kind of mathematics. And what I mean by that is that numbers play along differently. Imagine you have a clock divided into 12 parts. So you have 12 here, 3 there, 6 there, 9, and then you have all the other divisions. When it's 1 o'clock, in 2 hours' time, it's going to be 3 o'clock. In 2 hours' time is going to be 5, 7, 9, 11. But when it's 11 p.m. or a.m. and it's 2 hours later, it's not 13 o'clock, it's 1 o'clock. And the reason is that there is a circular number line in the clock. So when it starts from 1, 2, 3, all the way up to 12, it continues at 1, 2, all the way up to 12 again, and so on and so forth. And so this kind of number line is kind of cyclic instead of the normal real number line that we know of. And so modular arithmetic is simply a mode in which numbers go round and round within a particular set. And so you can count only up to a certain number, and then when you reach that number, you are supposed to start again. Let's try and get a few examples to see. So if you are dealing with, for example, a number in mode 5 or modulo 5, then 1 in modulo 5 will be 1, or will be congruent to 1. 2 in modulo 5 is 2. 3 in modulo 5 is 3. 4 in modulo 5 is 4. 5 in modulo 5 is either 5 or 0, and the correct answer would be 0, which we will explain later. But when you come to 6, you have to come all the way back to 1, because we are dealing with modulo 5. And so depending on which modulo or which number we are dealing with, whenever you reach that number in terms of counting, you go back to the start of the counting process. Another way to think of modular arithmetic is in terms of remainder. And for the rest of this class, we are going to actually look at modular arithmetic in terms of remainder. So suppose you have a division question like 12 divided by 7. You're trying to divide 12 items amongst 7 people equally. We all know that this is going to be 1 remainder 5. What this means is that if we are treating 12 in mode 7, or modulo 7, then our results will be congruent to 5. Or you can say 12 is equal to, or is congruent to 5 mode 7. So here's the catch. Whenever you are trying to find a number in terms of the mode of another number or modulo of another number, you are always supposed to focus on the remainder. Focus on the remainder. That is the motto of this topic. Okay, always focus on the remainder. So 12 divided by 7 will be 1 remainder 5. And 5 is going to be our answer for 12 in mode 7. Let's take some more examples to enhance your understanding of this explanation. So, let's simplify the following. A, 57 in mode 7. B, 32 in mode 12. C, 23 in mode 3. And D, 68 in mode 7. Let's look at the solution to these questions. So, we are trying to find 57 in mode 7. The first step towards solving this problem is to divide 57 by 7 and find what the remainder will be. And so when you look at this, 57 divided by 7 will be 8 remainder 1. And the focus should always be the remainder, right? So it means that 57 mod 7 is congruent to 1. Simple, right? In the same way, 32 in mode 12. When you are trying to divide 32 by 12, we know that 32 divided by 12 would be 2 remainder 8, right? Because 12 1 is 2, 12 2 is 24, 12 3 is 36. That's more than 32, so we can't really say it's 3. So 12 can divide, 32 can be divided into 2 different groups when we are sharing it amongst 12 people, and there will be 8 remaining. So since our remainder is 8, then this is congruent to 8. And that's our final answer. C, I'm sure by now you are getting into the concepts and you are getting familiar with it. And so let's get right into this. 23 mode 3. 23 mode 3. So 23 divided by 3 is 7 remainder 2. And so since 2 is the remainder, then this is equal to 2, or it's congruent to 2. I'm sure it's almost so easy for you now. So 68 in mode 7 will be, so 68 divided by 7 will be what? 68 divided by 7 will be 9 remainder 5. So that will be 5. So that's basically the concept of modular arithmetic. Whenever you are dealing with any big number or any number at all in a particular mode, what you do is you do the division and look at the remainder. So your answer would be that particular remainder. Now let's look at a few rules with the process of modular arithmetic. Few rules with the process of modular arithmetic, or modular arithmetic. Yeah, very, very important rules that you need to consider. So let's look at the first rule. So the first rule is that if the number you are going to divide the modular number with is a factor of that number, then your answer is 0. So if A divided by B will leave a remainder of 0, then A mod B is 0. So you can take an example. For example, if you have 56 mod 7, 7 can completely go into 56 with no remainder at all, because 7 times 8 is exactly 56, and we already know that. So 56 divided by 7 is going to be 8 remainder 0. So 0 will be our answer. So whenever you are dealing with two numbers, one in the mode and one being the number that we're going to use in finding our answer in that mode, then what we are going to do is, if the modular number is a factor of that big number, so in this case 7 is a factor of 56, right? So if 7 is a factor of 56, then our answer is straight away 0. It's the same way if you have 4 mod 2. Since 2 is a factor of 4, then we know that the final answer would be 0. So that's the first rule. Let's look at another rule. Another rule is that if you have A mod B and A is less than B, and both A and b are positive, then A mod B is A. This looks like a complicated sentence, but it's actually very, very, very simple. So all you're saying is, if you have A modulo B, if you're trying to find A in mode B, and A is less than B, and both of them are positive, then your final answer is A. So for example, 2 mod 5 is 2. Okay, and the reason being that if you are dividing 2 by 5, it will be 0 remainder 2. So it's always about the remainder, right? Because 5 can't, if you have 5 people and you want to divide 2 items among them equally, you can't do that, right? So that will be 0 and there will be 2 remaining. So you have 0 remainder 2, which will be 2. In the same way, 4 remainder, sorry, what I actually meant by that is 4 mod 8 is 4. Okay, so whenever you are dealing with these kinds of operations, you know that when the number to be transformed by the modular number is less than the modular number itself, then the final answer is the number to be transformed. Okay, so this is also another rule, very, very important. Let's look at another one. Towards we'll solve some examples. So the other rule is when you are dealing with negative numbers. Okay, negative numbers. So for example, if you have negative 2 mod 5, how do you go about it? Okay, so the rule in or the rule concerning going about the mode of a negative number is to keep adding the modular number to the negative number until you get a positive number. Okay, so this is how to go about such a problem. If you have negative 2 mod 5, you start adding 5 to negative 2 until you get a positive number. So let's go ahead and start the process. So we have negative 2 plus 5, and we have 3. So our final answer is 3. Okay, this is different from when you are dealing with positive numbers. Okay, you don't do all the division remainder stuff, but with negative numbers, you just keep adding the modular number until you get a positive number. Another example would be negative 12 mod 9. Okay, so negative 12 plus 9 is negative 3. Because this negative 3 is not a positive number yet, we need to keep adding. So we add 9 again to negative 3 and we get positive 6. So now we have a positive number, right? So our final answer for this would be 6. In the same way, if you have negative 4 mod 3, you have negative 4 plus 3, which will give you negative 1. And when you add negative 1 to another 3, you'll get 2. So this is 2. That's the final answer. So when you are dealing with negative numbers, okay, you need to keep adding the modular number, and when you add the modular number, you do so until you get a positive number, and that positive number will be your final answer. Okay, let's get into one last rule, and then we'll deal with addition and multiplication tables, and we'll be through with this particular class, or the first part of this entire topic. I hope you are familiarizing yourself with the topic. It's quite an interesting topic. Okay, so if you have, say, A plus B mode in mode C, this rule states that whenever you have an operation sign between two numbers before the mode comes, okay, perform the operation first before you consider finding the mode. Okay, so let's take some examples. Okay, say you have 2 plus 5, 2 plus 5 mode mode 3. Okay, 2 plus 5 mode 3. So what this rule states is that you need to perform this operation first, and 2 plus 5 is 7. So 7 mode 3 would be 1, because 7 divided by 3 will be 2 remainder 1. So your final answer will be 1. In the same way, if you are dealing with negative 10 plus 2 mode 6, you have to perform this operation first. So negative 10 plus 2 is negative 8 mode 6. And we've already learned how to deal with negative numbers in modular arithmetic. So you keep adding. So you have negative 8 plus 6 is equal to negative 2. Then you add negative 2 to another 6. You have positive 4. So now you have a positive number. And so the final answer would be 4. Now this particular sign here can be any of the 4 main arithmetic operation signs. So it can be multiplication. For example, you can have 2 times 6 mode 5, which will in this case be 12 mode 5, and 12 mode 5 would be, guess it. All right, that's 2, because 12 divided by 5 will be 2, remainder 2. Okay, 2 times 5 is 10, and there'll be 2 left to add on to the 12. If you have 8 divided by 2 mode 3, you have 8 divided by 2 to be 4, and 4 mode 3 is congruent to 1, because 4 divided by 3 will be 1 remainder 1. So it's always about the remainder when we are dealing with positive numbers. So these are basically the rules that you should know about in modular arithmetic. They are very important, and so once you know this, you can delve straight into any kind of problem in relation to modular arithmetic. Another thing I would want to put across is that the operation between two numbers is not always a singular operation. Sometimes you may have a binary operation system, which I may explain later in a later video or another section of this same topic. Okay. This brings us to the end of the first part of this video or this topic entitled Modular Arithmetic. I'm sure you enjoyed the video, and I hope to see you in another video, and I hope to spend another time with you. Please don't forget to like my video and subscribe to my channel. Share the video with your friends